In this video, I'm going to go over how you convert between atoms, moles, and grams. And this video specifically is for elements, although the same general idea will also work for compounds. So in this first example, and I don't have every variation that you can come up with here for problems, but this will give you a pretty good idea on how to do them. How many grams are in 12.5 moles of copper? Just like any other conversion, always start off with the number and units that you are given. So 12.5 moles of copper. Since you start off with moles of copper, that's what goes on the bottom, moles of copper. And what we're looking for is grams. So we'll put that up top, grams of copper. When you are doing a conversion factor, remember that this is an equality. These things have to be equal. It's like saying 60 seconds is a minute. They represent the same thing, you just have different numbers because the units are different. Well, for this, it's the same idea. We need to come up with an equality between grams and moles. And when you're doing that, the number 1 always goes with moles. It's nice and easy to do it that way. And now to figure out the grams, you go to the periodic table. You find copper, which is atomic number 29, and you get the molar mass, which is 63.546, and I'm perfectly fine with you rounding that off to 1 decimal point, so 63.5. Now you multiply across the top, 12.5 times 63.5, and that gives you 793.75 grams. Pay attention to significant digits. You never go by the conversion factor because this is a known value. You didn't measure this, so it's an infinite number of significant digits. Go by the number in the problem. 12.5 is 3 significant digits, so we have to round this off to 3 significant digits, and we get 794 grams of copper. That ends up being the answer for that one. For the next one down, how many atoms are in 5.45 moles of sodium? So I'm not talking grams here. So since grams doesn't come up in this problem, we're going to have to do it a little different. 5.45 moles of sodium. And again, whatever units you start off with, they go on the bottom. So moles of sodium. Now what we're converting to is atoms. Well, just like we did in this first problem, the number 1 always goes with moles, and we have to set up an equality here. This is where we need Avogadro's number. Atoms are extremely small, so you need an extremely large number to go with them, and this is Avogadro's number, 6.02 times 10 to the 23rd. Atoms are in 1 mole, and it doesn't matter what element you have. If you have 1 mole of it, you have Avogadro's number. So we didn't even have to go to the periodic table for this one since grams doesn't come up at all. Now what you do is 5.45 multiplied by Avogadro's number. Rounding it off, you get the correct number of significant digits. You get 3.28 times 10 to the 24th atoms. We're talking about sodium. Alright, so grams doesn't come up in that problem. Remember, what works well is to figure out what the units are and then get the numbers that go with them. Now the next one is going to be a little different. How many atoms are in 30 grams of zinc? Again, start off with the number and units that you're given, 30.0 grams of zinc. Grams is going to go on the bottom. We're looking for atoms, so they go on top. Alright, we're going to set up another equality here. The word moles isn't coming up anywhere, so we're not going to use 1 mole in this conversion factor. Anytime it's asking for grams like this, you go to the periodic table, you get the molar mass, and you round it off to 1 decimal point. So it's 65.4 grams of zinc, which is a mole. And now we need how many atoms are in a mole? 6.02 times 10 to the 23rd. Remember, these things are an equality. The numbers are very, very different because the units are very different. But if you have 1 mole of zinc, you have 65.4 grams of it, and you also have 6.02 times 10 to the 23rd atoms. So now what you do is 30 multiplied by Avogadro's number divided by the molar mass, which is 65.4. Round it off to the number of significant digits in the problem, and you get 2.76 times 10 to the 23rd atoms of zinc. So remember, for conversion factors, we're working with three different things at this point. You have moles, and it's always 1 mole in the conversion factor. We are working with atoms. It's always 6.02 times 10 to the 23rd. And we are working with grams, and that's always from the periodic table. It is the molar mass. They are the three variables that we have right now. Now, eventually, we'll work with compounds instead of just elements, and you would just end up getting the molar mass of the compound, and instead of atoms, it would be 6.02 times 10 to the 23rd molecules. The general idea is the same, just the terminology changes a little different.